Hello and welcome back. I'm Professor Ridge, and for today's lesson we'll be covering section 1.2, operations and properties of real numbers. Our first objective that we'll be covering will be absolute value. So let's start off with that definition. Okay, so an absolute value okay, we'll start off with the notation. The notation is two straight bars. So the way you read this is the absolute value of A. The absolute value of A. And that represents the number of units that A is from 0. So we can think of absolute value as a distance. The distance that a number is from 0. And the thing keep in mind when you measure distance is we don't care what direction we're going, from left to right, right to left. You just, if you had a tape measure, and if I were to, it doesn't matter which end I hold, and I pull it towards you and say we're 5 feet apart, it's not going to say 5 feet if I bring it from me to you, or if you bring it from you to me, it's still going to be 5 feet. So distance is, we don't care about direction. So if I was right here at 3, and I asked you, well, what's the absolute value of 3? Sorry, absolute value of 3. And we're going to say, well, how far is it from 0 to 3? What's that distance? 1, 2, 3 units. So absolute value of 3 is equal to 3. Now if I was over here at -4, and I wanted to know the distance from -4 to 0, again, it doesn't matter how we measure this, from left to right, right to left, that distance is going to be 1, 2, 3, 4 units. So the absolute value of -4 is 4. Right? So as simple as that. If a number is negative, let's do a couple more. So again, if the number is negative, so I want the absolute value of -8, you're just going to make it a positive number. You're just going to, a couple ways you can think of it. One way I like to think of it is just the number without the sign. So if it's -8, you drop the sign, absolute value of -8 is 8. Absolute value of +7. Now in practice, we don't generally write positive signs, right? If you don't see a sign, you say it's positive, but technically, whether I write it or not, that's +7. So the absolute value of 7, again, if I think of it as, okay, it's just the number, drop the sign, the absolute value of +7 is just 7. And it doesn't matter if it's a whole number, a fraction, decimal, same thing. If they're negative numbers, drop the sign, make it positive. Positive numbers, drop the sign, it's just the number. So the absolute value of -4.75 would just be 4.75. If I have a fraction, absolute value of 3/5 is just 3/5. And then what about 0? If I was up here at 0, how many units away is 0 from 0? Right. Absolute value of 0 is 0. Oops, sorry about that. Okay, so that's absolute value. Pretty straightforward. Yet most of the topics we're covering today, pretty much all the topics we're covering today, should be reviewed for you. So we'll kind of go a little quickly. So next topic is inequalities. And basically inequalities are things that are not equal. So equations are with equal sign, and inequalities are statements with these symbols. So these are inequalities. Not equal to is an inequality. And then, so these are considered strict inequalities. I'm not going to write that down, but if you put the little bar underneath, what does that mean? All right, so let's write down. So this symbol is, now a lot of people will say less than, and technically that's not right. It's is less than. That is very important. I'll show you an example after we write them all of why that's important. This one is greater than. Is not equal to. I forgot the 2. So this one will be is less than. And then the line underneath is unequal to. So it's basically a compound statement that is less than, or, and then that's an equal to. And then this would be greater than or equal to. And I forgot to say is, didn't I? Is greater than. So I usually get people with this in class. I'll show you what I'm talking about, why that is important. Because if you forgot to write the is, what is 5 less than what does 5 less than 8 translate to? And this actually translates to 8 minus 5. Okay? If I wrote 5 is less than 8, that would translate to the inequality. So this is a complete sentence. 5 is less than 8 translates to that inequality. Okay? So if you forget the is, this 5 is less than 8 is actually just 3. It's this statement, expression. And then another, just to point out, just to remind you if you forgot, when we talk about compound statements in math, an OR statement says that if you meet either this condition or this condition, then the statement would be true. So an OR statement is more inclusive. So either of these conditions is true, then the whole statement's true. Okay, now in math, an AND statement would say that both conditions would have to be true for it to be a true statement. So if I asked you to decide whether it's a true statement or false, determine whether true or false. Say if I had like 8 is greater than or equal to 10. And again, if you recall, on the number line, the numbers get bigger as you move from left to right. So if I think about 8 on the number line and 10 over here, 10 is actually bigger than 8. So is 8 greater than 10? No. Is 8 equal to 10? No. So since both of those are false, then the whole statement's false. So remember, an or statement, if either one's true, then the whole statement's true. So if I asked you, is 6 less than or equal to 6, is 6 less than 6? And the answer is no. Is 6 equal to 6? Yes. So since one of those two statements were true, the whole thing's true. So for an or statement, if either condition is true, then the whole statement's true. Okay, so I just wanted to point that out to you. And if you're not sure whether it's what happened there? Okay, just some minor technical issue there. All right, so again, it doesn't matter if you're not sure whether if it's true or false, and you think about the number line, that should help you. Usually with negative numbers, it's helpful to think about the number line. So is negative 8 greater than negative 6? And again, if you think about the number line, negative 8's over here, negative 6 is over here, and again, as you move from left to right, the numbers get bigger. So negative 6 is bigger than negative 8. So is negative 8 greater than negative 6? That would be false. Okay, so now we'll move on to addition, subtraction, and opposites. And that should all be reviewed for you. So I am not going to actually do any of those. You can do the homework on my math lab, and you should be fine. The one thing I do want to point out that's confusing for some people is if I asked you to find the opposite. And the way we write it in symbols is you would say, if I asked you to evaluate, and a lot of people read this as negative x, but no, you should read that as the opposite of x. Okay, so if you read that as the opposite of x, then you shouldn't have too many problems. So if I ask you to find the opposite of x when x equals 10, then the opposite of 10 is going to be negative 10. Find the opposite of x when x equals negative 5, then the opposite of x is the opposite of negative 5, which is 5. Okay. If I say what's the opposite of x when x equals 0, then the opposite of x, the opposite of 0, 0 is the only number that its opposite is itself. So the opposite of 0 is just 0. Okay. The big thing about subtracting, just let's talk about that a little bit. Notice that I wasn't going to do any of these. Okay, subtraction. A minus B is equal to A plus the opposite of B. So in algebra, a lot of times it's important that we think, even though a lot of times we'll think of that as a minus sign, it's important that you think about it this way. It's adding the opposite. So if I wanted to do 6 minus 8, whether I write it or not, it's still important to think of it this way. It's going to be 6 plus a negative 8. And then just review the rules real quickly. If the signs are different, you're going to subtract the numbers. 8 minus 6 is 2. And then you're going to take the sign of the larger absolute value number. So 8 is bigger than 6, so I take the sign of 8. That's negative 2. Okay, so that's a quick review of adding positive and negative numbers. If the signs are the same, then you add and keep the sign. If the signs are different, you subtract, and then you take the sign of the larger number. So if I had like negative 8 minus 10, that's the same thing as negative 8 plus. Now 10, see, if I think of this as a minus sign, that's a positive 10. So negative 8 minus positive 10, by definition of subtraction, I'm going to leave the first one alone, and then I'm going to add the opposite of that number. So this is going to be negative 8 plus, and then I'm going to change this to be negative 10. So now I'm going to do my addition rules. Signs are the same, so I keep the sign and just add the numbers. So 8 plus 10 is 18, keep the sign, so it's negative 18. All right. All right, so now we're going to use multiplication, division, and reciprocals. So again, that should all be reviewed for you. But when you're multiplying or dividing two numbers with the same sign, so it doesn't matter what you're doing, to multiply or divide two numbers with unlike signs, you're going to just multiply or divide their numbers. So technically they're absolute values. So I just think of it, just ignore the sign. So multiply or divide, ignore the sign. And then the answer is negative. So if one number is positive, one number is negative, you just multiply or divide the numbers, whatever you're doing, ignore the sign, and then the answer is going to be negative. So positive times a negative, or negative times a positive, doesn't matter which number is bigger, which number is smaller. One's positive, one's negative, the answer is going to be negative. Now, if they're the same sign, so if they're both positive or both negative, then the answer is going to be positive. And this should all be reviewed, but just in case, good refresher. So again, I just say, okay, so if you're going to multiply or divide two numbers, just multiply or divide them, ignore the sign. If one's positive, one's negative, the answer is negative. If they're both the same, if they're both positive or both negative, then the answer will be positive. So I go -8 times 5. So again, I just ignore the signs. 8 times 5 is 40. And then if one's positive, one's negative, doesn't matter which. If one's positive, one's negative, then the answer is negative. So that's -40. So it doesn't matter which way you do it. You can do the numbers first and then think about the sign. You do the sign first and then think about the number. But either way, you could think of it as as two distinct steps. Okay, so 8 times 5 is 40. Positive times a negative is negative. If I had -8 times -5, 8 times 5 is still 40. Two negative. If they're both negative, signs are the same, then the answer is positive. Of course, you don't have to write the plus sign. I'm just doing it to emphasize the answer here. If if I had 8 times -5, well, 8 times 5 is still 40, and then positive times a negative is negative. All right. The next thing on here, we talk about a sign of a fraction. We'll actually talk about this quite a bit when we get into the chapter on rational expressions, where we do a lot of fractions. But it's good to review right now. So for any number A and non-zero number B, I'm going to write that. -A over B equals A over -B equals, so we're thinking of A and B as positive numbers. But actually they don't have to be. So if I had -3, well, let's do it, -30 over 10. What's -30 divided by 10? Well, 30 divided by 10 is 3. Positive and a negative makes negative. If I put the negative on the bottom, 30 divided by 10, -10, is still going to be 30 divided by 10 is still going to be 3, and then positive and negative make negative. And then the last one, if I did the opposite of 30 divided by 10, well, 30 divided by 10 is 3, and then the opposite of that would be -3. Okay, so you can see all three of those give you the same result when you're done. So they're all equivalent to each other. So the way I think of it is I can take that negative sign, take the negative sign, and I can move it around. If it's on bottom, I can push it up to the top. If it's on top, I can push it to the bottom, or I can put it out to the side. Technically, this is the way considered the simplified form. But me personally, in use, I like to write it this way. So whenever I have a negative on the bottom, I push it up to the top. Okay. The law of reciprocals. For any two numbers, A and 1 over A cannot be equal to 0. A times 1 over A equals 1. So any number, so the way we read this 1 over A, that you could also say that's the reciprocal of A. So any number times its reciprocal is equal to 1. That's the law of reciprocal. So the product of a number and its reciprocal is 1. That's the law of reciprocals. So we're going to cover a lot of all the rules, laws, properties, commutative law, associative, and distributive laws. And before we get to that, I got to talk about division by zero, what I put here. So any number, we're not allowed to divide by zero. We never divide by zero. Division by zero is not allowed. This is a box in your book. And so any number divided by zero, we say is undefined. You don't get a number. If you have 0 divided by 0, that's actually, for our purposes, we'll just say undefined, but it's actually indeterminate. So in calculus, when you get into talking about limits and you end up with 0 divided by 0, you're not sure whether it's going to be infinite or something else. So it actually is indeterminate. But that's for a much later discussion. But so basically, for our purposes, anytime you have 0 on the bottom, just say undefined. You don't need to worry about this so much right now. Okay, so now on to the commutative, associative, and distributive laws. So the first one there, commutative, and usually in class I ask the class, so when you hear the base word in here is commute. So if you hear the word commute, what do you think of? What comes to mind? And typically I get answers, a few different things, and typically I'll hear something about, driving to work. My commute was long today. And basically it's kind of along those lines. So when I commute to work, I'm trying to get from here to there, from point A to point B. I'm trying to move my position from here to there. And that's really what commutative law is. It's talking about moving things around, changing the order. It's order. So the commutative law for any real number A and B, A plus B equals B plus A. That's your addition property. That's the commutative law for addition. And then A times B equals B times A. So after we talk about, what does it mean, what's commute mean, and we talk, it's moving around, getting from here to there. And then for these purposes, we're moving around the order, we're switching the order. So if I ask you what's the commutative law of addition, and you say, well, A plus B equals B plus A, yeah, but actually I want you to make it more meaningful, translate it some. So the way I would ask you to state it without saying A or B. And basically what this says is that if you switch the order of an addition problem, right, so if A plus B, and then I switch the order, B plus A, So if I switch the order of addition, what happens? You get the same result. That's what that says. So you're allowed to switch the order. If I have 5 plus 8, that's 13. If I switch that order around, 8 plus 5 is still 13. So addition's commutative. That's the way we say it. Same for multiplying. 2 times 3 equals 6. If I switch the order around, it's still 6. Okay. Multiplication and addition is commutative, but no, subtraction and division is not. Five minus 8 is negative 3. If I switch the order, 8 minus 5 is positive 3. So that does not equal. You don't get the same result when you switch the order of subtraction. That's important to understand. So for multiplication and division, it's okay. For subtraction, can't do it. Division, can't do it. So if I had 4 divided by 2, that equals 2. 2 divided by 4, that equals 1/2. So you get a totally different answer. Okay, so that's the commutative law. Next one, associative. All right, so the base word here is associate. So if I think about associates, who I associate with, the people I hang out with, my group, people I work with, right? That's associate. Associate. So for this, so again, for any real numbers, A, B, and C, A plus B plus C equals A plus B. And again, I use the word, the people I hang out with, people I work with, my grouping. That's the key thing for associative. It's grouping. So for commutative, it's switching the order. For associative law, it's grouping. So this is addition. So the group here is B and C. They're grouped together. Over here, A and B are grouped together. And we're saying it doesn't matter which way you group it, you're going to get the same result. And then we do multiplication. So a real quick example, we'll just do the addition one. So add, subtract, multiply, divide are what are considered binary operations. If you have two numbers and you do this binary operation, so like if I did 3 plus 4 plus 5, if you think back to the beginning when you first learned about adding, we memorized the math facts with just two numbers. We just memorized 3 plus 4, not 3 plus 4 plus 5. So the way that we would add three numbers or more is you're going to add just two at a time. So you do 3 plus 4, get an answer, and you take that answer and then add it to 5. So the associative property says, well, it doesn't matter how you lump those together into your groups of two. You can do these two first, and you're going to get 3 plus 4 plus 5 is 9. Well, I don't need the parentheses now. And then the 3 plus 9 is 12. And then what this property says is, well, if I group it this way, 3 plus 4 is 7, plus 5. 7 plus 5 is 12. You're going to get the same result. Okay, so that's the associative law, how they're grouped together, how you lump them together. All right. And then the distributive law, the last one here. I always think of this as my backdoor away around the order of operations. So again, for any, I'll explain that in a second. A, B, and C. So here's what I mean. So if I had numbers for all these, 5 times 3 plus 6. According to the distributive property, I can do 5 times 3 plus 5 times 6. Now, if I were doing order operations, I would have to do inside the grouping symbols first. So 3 plus 6 is 9, and then 5 times 9 is 45. Okay. Now, over here, this is the alternate way to do the same problem. I can do the 5 times 3, which is 15. I can do the 5 times 6. 5 times 6 is 30. And then add those two numbers. See, I still get 45. Okay. Now, the reason I'm saying that's a backdoor to my order operations, it's an alternate way of doing it, is if we didn't have this property, a lot of math expressions, algebraic expressions, we'd be stuck. Because by order operations, I have to work this out first and then times it by 5. Well, if I don't know what x is, then I'm stuck. I can't do anything. But luckily, we have the distributive law. Since we don't know what x is, my way around the order operations is I'm going to distribute the 5. And I know this expression is equivalent to 5 times 2 is 10. So it's going to be 5x plus 10. So that's kind of like my backdoor way to get around the order operations. Okay, so that concludes lesson number 2, section 1.2. So go on to My Math Lab and do the homework assignments that I have assigned for you there. And I will see you for the next lesson.